Computers and routers do not understand human-readable IP addresses. Under the hood, they communicate entirely in raw streams of binary, endless strings of ones and zeros. For newer technologies like IPv6 and Ethernet MAC addresses, even binary gets too long to manage. That requires a shift to hexadecimal, a base 16 system that mixes both numbers and letters. The objective here is to learn the exact shortcuts network administrators use to manually translate between decimal, binary, and hexadecimal, all without relying on a calculator. To follow along, grab a pen and a blank piece of paper. We are going to build the master cheat sheet you will use for every conversion. Seamlessly translating between human decimal formatting and machine languages is a required, non-negotiable skill for any network technician. Looking at this diagram, start on the far right of your paper. Write the number 1 and keep doubling it as you move left. This sequence stops at 128, giving you a specific 8-number line: 128, 64, 32, 16, 8, 4, 2, and 1. A quick warning: never write the sequence left to right starting with 1. The 128 must always sit on the far left side of your page. In networking terms, this 8-number sequence represents exactly 1 byte, or 8 bits, of an IPv4 address. Memorizing this single sequence replaces complex math with basic addition, making manual conversions fast enough to use during live troubleshooting. This table shows our first task: converting the standard decimal number 168 into an 8-bit binary sequence. This flowchart shows the greedy method. Just ask, does the biggest number fit? For 168, 128 fits, write 1, leaving 40. 64 doesn't, write 0. 32 fits, write 1, leaving 8. 16 doesn't. 8 fits exactly, write 1, leaving 0. The remaining columns get zeros. Hitting a remainder of exactly 0 at the end of the sequence serves as your built-in proof. It confirms your final binary conversion is entirely accurate. This table shows a binary sequence under positional values. Let's decipher 11000000. Write it under the numbers on your cheat sheet. The rule is simple. Completely ignore columns where the bit is 0 and add the values where it's 1. Here, add 128 and 64. 128 plus 64 equals 192. Decoding machine language back into dotted decimal IP addresses requires no advanced math at all. This graphic shows a full IPv6 address, and its extreme length demonstrates exactly why we use hexadecimal. Base 16 formatting compresses massive binary strings into something manageable. Before calculating, keep this critical rule in mind to prevent errors. Never attempt to convert decimal directly to hex. Always convert your number to binary first and use it as the middleman. This infographic shows a shortcut. Every hex digit maps to exactly 4 bits, a nibble. Take the byte 10101000 and split it into halves, 1010 and 1000. Apply an 8421 sheet to each. The left equals 10, translating to hex A. The right equals 8. Combine those two results to get A8. Breaking bytes into 4-bit nibbles turns a base 16 calculation into 2 tiny addition problems. With just those 8 numbers on your cheat sheet, you can now translate IPv4 addresses, read machine binary, and convert bytes into hexadecimal values. Just remember to memorize the hex letter equivalents, where A equals 10 up through F equaling 15. That ensures you won't freeze up when calculating values higher than 9. Now it's time to practice. Log into your home router, find your own IP address, like 192.168.1.1, and convert all 4 sections into binary. This cheat sheet is the foundation for your next stage of training. When you eventually learn to divide large networks into smaller segments, a process called subnetting, you will use these exact binary conversions to find the boundaries of every network you manage.